I'm going to start working on the electronics box. This aluminum box that came with the kit. Got to mount the power supplies and the drivers, breakout board. I've already mounted the power plug in the back where you can plug like a computer cord into to get power, and a on-off switch. Looks like it's an illuminated on-off switch, and a e-stop button. I also went ahead and drilled the holes to mount the DB9 connectors for the stepper motors. What I'm going to do now is put a plywood bottom on the bottom of this, 1/2-inch plywood that I had in the basement, just to make it a little sturdier, give me something more than just this aluminum sheet metal to screw everything down to. So I've got a piece of that cut to go under it. I'm just going to kind of line it up and drill some holes through there and put some maybe number 6 screws in it, maybe number 4s. I'll see what I got. Found some number 4 screws that I had, so I'm going to use those, 1/2-inch long, to screw this aluminum box to the 1/2-inch plywood. I went ahead and marked off some holes here in pencil, so actually I'm going to use this punch to start a hole. Make the drill bit so it won't ride around. Trying to drill just through the aluminum, not go too deep into the wood, or else my screw won't hold. Be pretty good. Well, the next thing to do is to set these components kind of where we want to put them at for convenience and for airflow. Drivers in here like that. We've got 4 drivers. There's 2 for the Y-axis and 1 X and 1 for Z. Leave some space between those for airflow. I think I'll mount a fan in here too. Went ahead and got the power supplies and the drivers screwed down to the box. Use some number 6 screws on the drivers and number 4s on the power supplies. I went ahead and turned the power supplies around the other direction to put the terminals closer to the plug. Make it a little more convenient to wire. So the next thing to do is run the power wires. I've got the hot wire running from the plug to the switch and then back from the switch to the 2 power supplies, jumping from one to the other. Now I'm going to hook up the neutral wire from the plug to the power supplies. Okay, now the ground. Okay, there's the hot, neutral, and ground hooked up. So let me get a cord and plug in and we'll test it and make sure it's okay. Okay, I've got a cord hooked up to a receptacle. Now let's check and see what voltage we got. Make sure we got our 120. Now let's see if we got anything at the power supply. Nothing yet. We have to turn the switch on. So let's turn the switch on and see what happens. I can hear the fans of the power supply. Evidently that on-off switch is not an illuminated one because it didn't light up. Thought maybe it was illuminated the way it looked, but you can hear the fans going. Now we have 120 volts on that power supply and that power supply. But now from common to voltage plus on the power supply is exactly 36 volts on that one. And 36 volts on that one. So we're in good shape with power. So let's cut it off. Now we can start running some wires from the power supplies to the drivers. Right now I'm working on wiring the 36 volt from the power supplies to the stepper drivers. I've got two of them wired up, getting ready to wire the third one up. Well, there's three of them wired up. Got one more to go. I'm getting ready to solder the wires onto the DB9 connectors, which will mount in the front of the panel box for the cables that go to the stepper motors. Four wires per motor, so I'm going to use the bottom 4 pins on the DB9s. So we'll start tinning the wires. Set my soldering iron hot enough. There's the first connector on. 3 more to do. Then we got to cut the wires and connect them to the drivers on those 4 ports there. Make sure we get the pairs right. We got red and green and yellow and blue. So we'll take yellow and blue and go to B plus and B negative. Going to put 1 wire tie on these just to hold them together in case I have to reverse any of these wires, the A's and the B's. I forgot I was going to put heat shrink tubing on these to keep them, any chance of these from touching on the connectors before I put them in the terminals, but so I took them back out to go ahead and put the heat shrink on now. Hopefully that's good enough. Put the wires back in terminal and move on to the next one. I'm working on this cutout on the back of the panel box for the parallel port. There was a short slot that they had put in here. It wasn't long enough, so I marked it off and drilled some little holes in here. Took a pair of dikes and kind of broke that piece out. Took a filed it up so that the parallel port would fit through there. Drilled a couple of pilot holes on each side for the little hex nut where you screw the other part to. So I'm getting ready to drill that out a little bigger so they'll pop through there. Take a file and clean that up a little bit. I had to do a little filing around the opening, and the one hole here was a little bit off center, so I had to do a little filing on that, a little round file. But I've got it to where it'll fit in there now. So we just have to mount it down on the inside. I've got these little plastic bushings to use as a standoff. Had 1/4 inch ones, and I just glued 2 of them together and had to sand them down just a little bit to get the right height. So we're ready to put the little circuit board in, the parallel port. Right now I'm getting ready to wire up the breakout board to the drivers. According to the diagram they sent, it only takes 3 wires to the breakout board and a jumper from CP plus to DIR plus on the driver. So I went ahead and labeled on the inside here X, Y, XZ, and Y1, Y2. There's 2 Y steppers on this machine. The color coding, just so happens the cable I got has the right color to the print, so that makes it easier. Green goes to DIR plus to, well, I'm going to start with the Z axis. The one on the end here is going to go to DIR minus to number 5. Go ahead and put the other 3 in this side while we're here. The red goes to CP minus, which on this driver is pull minus. And then black goes to pull plus with a jumper over to DIR plus. Then find a small jumper wire. A little bit lighter weight wire, but I think it'll be okay. Okay, that takes care of that end. Okay. Green goes to 5. These are little push connectors, you don't have a screw terminal. Red goes to 4. And black goes to common. Might need to try to get them all in there at one time. There we go. Okay, I finished up the wiring to the breakout board from the drivers. Give you a close-up shot of that. Went ahead and tidied up the wires a little bit, tied them together and anchored them down. I'm getting ready to mount a receptacle in the box to plug the fan and the 5-volt power supply in. The fan that I got was a 120-volt fan because I couldn't find one that was 36 volt, which is what these power supplies are, so they only made 12 and 48 volts, so I decided to buy a 120-volt fan. And so I'm going to mount the receptacle right here, feed it off the power supply on the line side, the 120 side, feed this receptacle. So I'm going to mount this box down and put the receptacle in. Okay, I've got the 5-volt power supply plugged in, shortened the cord and wired it directly to the 5-volt and enable and ground. I don't think I need a enable switch. I just jumped it right to it. I think that's the complete panel box now. I went ahead and did connect up the e-stop earlier to these two wires right here. So the e-stop's connected, and I did figure out why I was not getting the on-off switch illuminated. I didn't have the ground wire running to it, so I went ahead and ran the ground wire to it and back to the power supplies, and now the light works. I don't want to turn it on yet till I get the motors hooked up. That's going to be the next step, is to hook the motors up to it and test everything out.